Welcome to my talk called A Year in the React World. So, before anything else, my name is Daniel Afonso. I'm currently a front-end engineer at Seracare, and I'm also an Auth0 ambassador. You can find me on Twitter or on any social network at the handle at DanielJCAfonso. So, before anything else, my main ecosystem right now and the stuff that I'm mainly working with is JavaScript, React, and for testing, obviously, the testing library, which is one of the things that we'll end up seeing during this talk at the end of it. So, before anything else, what is this talk about? This talk is about a real-life case study that went over 2 years of building and growing a React application. During this talk, I'll approach stuff like why migrate to React hooks, how to deal with state management, and testing. So, let's start with the first point, which is hooks. So, before speaking about hooks, it's important to speak about class components. Class components have been around since the start of the React, and while they served as well, they have a couple of issues. The first one is giant and confusing components. What we can see here right now is a class component with 3 lifecycle functions: a component in mount, a component in update, and a component on mount. What we can see here is that inside of these lifecycle functions, there is unrelated logic grouped together on each lifecycle function. Right now, this might be readable, but imagine that we have a scenario that we need to add a bunch more logic to the component in mount or a bunch more logic to the component on mount. This will cause that unrelated logic stays grouped inside of the same live function and affects a bit of the readability of your code. And let's not even speak about how we are going to test this. The first point is reusing logic between components. So, if we were to think about what React offered natively before hooks, to how we can reuse stateful logic between components, we would think about stuff like make-sense, but they were deemed unsafe. And then we have patterns like I order components and render props. The thing is, these patterns often lead to code restructuring and adding extra complexity. And this leads to something that the React team refers to as wrapper hell, which is what we can see in this image. And the last one here is confusing classes. This one might be a bit controversial because I'm saying that classes can become confusing. In JavaScript, that is. So, before anything else, you have to understand how this works. You need to remember how to bind your event handlers on the constructor and all the related logic. All this usually leads to a bit of boilerplate code, and it might be a little bit verbose. And this is only for the human part. The React team has mentioned publicly often that for machines, classes don't minify properly, and this can cause issues on auto reloading and overall might introduce some erratic patterns. So it was to fix all these issues that the React team introduced React hooks. At the time, hooks had come around for 2 to 3 months, so they were still very recent, and we needed to have some justification to explain to our product team why did we want to take time in our development process to migrate to something that is very new. Well, the first selling point is that the React team has publicly mentioned that hooks are the direction where they intended on taking React, so hooks were the future of React. And here are another couple of motivations. The first one is code readability. So as you've seen previously, before hooks we had lifecycle functions. The thing with lifecycle functions is that they made us write grouped and unrelated logic on the same function. With hooks and introduction of effects, now we can split this code and group related logic together in each effect. So, this is a great aspect of hooks. The second point is code readability. So, as you saw previously, before hooks there was no way to reuse stateful logic between components. Then we had patterns like make sense, render props, or I order components, but as you can see that usually led to stuff that it's called the wrapper hell. With hooks and with the abilities of creating custom hooks, this now is possible and so much easier. And the last point is ease of teaching React. We knew that at the time we would soon be hiring some junior developers, and we wanted their onboarding process and ramp up to be as easy as possible. And we wanted them to get into the React ecosystem without many issues. And with hooks we wouldn't have to worry about all the stuff related to classes, so that was definitely a win. So as you can see, hooks are pretty great and they basically bring a new mindset to using React. We soon migrated our code to starting using hooks, and personally I can say that it cut the code in half, so we had half the lines we had previously. Everything was so much readable and easy to use. And Here are a couple of lessons that we learned while using hooks. The first one is pay attention to the rule of hooks, either it being things like not using hooks conditionally or forgetting some dependencies on a dependencies array. It's really important that you pay attention to this because that way you won't make mistakes that you will find later on. A thing that really helped us paying attention to the rules of hooks was static analysis. React has an SWint for rules of hooks. So this will make sure that these rules are fulfilled and we don't break anything. Now, the second point is don't pre-optimize everything. So React introduced two new hooks to deal with memoization, being it the useMemo and the useCallback hook. It's often said that premature optimization is the root of all evil. And with this in mind, we decided to follow an approach of trying to avoid memoization until it deemed itself necessary. Despite this approach, there are a couple of cases where we needed to memorize things, and there are a couple of lessons that we've learned. The first one is, if you're adding an always changing dependency to your dependencies array, then you probably shouldn't be memoizing that function, because if you're memoizing every time a dependency changes, it basically will be the same thing as if you're not memoizing it. And the second lesson was everything that's inside of your memoized function is memoized as well. So don't forget that the state of your functions used inside of your memoized contents will be the one before memoization. And this one was definitely tricky because we've had some issues with closures, because it would create closures of the previous value of our state. And when we went to use it, we were left to wonder why. Why was it using a state that it's not the current one? Yeah, don't forget about this. And the last lesson learned was how to deal and how to think in life cycles. So it's not thinking about life cycles, it's about how not to think in life cycles, because with hooks there was a new paradigm that was introduced. Instead of having life cycles, we now started to have side effects. And the way we could perform these side effects was by using the useEffect hook. Often in documentation or being in tutorials, useEffect is presented as a combination of the component in mount, as a component in update, and as a component we want mount life cycles. And this was one of the things that causes main issues. By advertising effects as the new life cycles, there will always be a comparison between them and for everyone that uses React pre-hooks. This led for us to writing effects the way we used to write life cycles, and even creating some custom hooks with the name of life cycles, like we had a hook for use mount effect or use unmount effect and stuff like that. And the catch here is that we didn't understand until a couple of months ago was that life cycles ran synchronously after render and blocked the browser from updating the screen, as effects generated by the useEffect ran asynchronously and were non-blocking. To use effects properly, we needed to forget how to use life cycles, and we had to start approaching React with a new perspective and thinking about effects instead of thinking about life cycles. And with these lessons learned, we can finally wrap the classes and React hooks topic. The next topic I would like to discuss in this case study is state. When we start a new project, there is a question that we always ask, and that question is, how will we manage state? There are a bunch of state management solutions in the market, and you can use either one. At the project I was in, we decided to start with Redux. Despite Redux being the most used state management library in the React world, it has a couple of issues in my opinion. The first one is it has too much boilerplate code. For you to start using Redux, you have to set up a bunch of things in your code. The second point is learning curve. Redux comes with a pretty big learning curve for someone who's not into state management at all. Despite this, it also has a bunch of need for middleware, so you often find that you need to start using either Redux Tunc or Redux Sagas and so on to start applying some effects or stuff like that. And I like to say that Redux is a necessary pre-optimization. I often do a comparison that, in my opinion, Redux in early stages of an application is like using a bazooka to try to kill a mosquito. And from this point, we decided to stop using Redux and move to React Context. And React Context is great, and we used it for over a year. There were just a couple of issues that we had with it. The first one was, am I getting unnecessary renders? But then I'll show you it in the next slide. The second one is related logic often gets regrouped into the same context, so that make your context a bit bulky with a bunch of code, and often to use context it has a bunch of boilerplate that you need to do as well. So as I mentioned, one thing that I've learned from context and I delved into was why am I getting some unnecessary renders, and I'll show you why. Here we create a couple of things. The first one is a random context. Then we create a custom hook to subscribing to our context called useRandomContext. Then we have a random store where we'll create two state variables and an effect that when the something variable changes, it will update the other thing variable. At the end, we have a random provider for wrapping our component that will use our context. So now, let's create our component. Here we have a component that subscribes to our random context and returns a button that when clicked it will update the something variable. At the end we have our component wrapped with our random provider to make sure that we can subscribe to our context. Now I guess we all have all the conditions that we might need to diagnose the issue. If we had a console log with I just rendered to the root of our component and we click our button, we should expect to see only one I just rendered because we are only updating the something variable, right? The thing here is what will happen is it will render twice I just rendered. Why? That is because we forgot something. We forgot that we have an effect that will update the other thing variable when the something variable changes. So when this happens, it will update our context and then our component that's subscribing to it will have to re-render to get the new values, even though it's not listening to those variables. Now, why does this happen? This happens because every time React detects a change to something inside of its context, it triggers a re-render on all the context subscribers so that they can receive new changes. And yeah, this is the issue of why am I getting unnecessary re-renders. Now, you might wonder, how do I fix this? Well, according to Dan Abramov, there are three solutions that you can try to fix this issue. The first one is split the contexts. This is actually the preferred approach and it consists on passing the variables that change too often to another context. In this case, what we do is we create a second context where we pass the other thing variable, removing it from the other context that we had. So this makes sure that when the other context changes, we don't have to worry about unnecessary rendering on our component because we will only be subscribing to the random context. The second approach is split the component in two and use Mimo. This approach basically consists of transferring the return of your first component to a second component, like we do in here. And in this second component, what happens is we'll wrap this component with Mimo and we receive the needed context variables as props. What this will do is, in case the first component re-renders, if we are listening to these variables and they don't change, then it won't be expensive because it won't do anything. It will return the same as you had because yeah, we are wrapping it with Mimo and saying only when something and set something changes, then this component will re-render. And then the third approach is wrap your return with use Mimo. If we don't want to split our component into two like we did previously, we can wrap the return part of our component with the use Mimo hook and only listen to the set something and something variables. Our component would still re-render, but the part inside of use Mimo, since it's memoized and listening to variables that didn't change, then it won't return until these variables change. So yeah, that's the ways of fixing unnecessary renders caused by your context. So even despite context serving us pretty great during a year and a half, we decided to stop using it. And one of the reasons why was our state was only comprised of service state. Now you might be wondering what server state is. Before anything else, it's important to know about global state. And you might wonder, hey, what's global state? Global state is the state that is comprised by the client state and the server state. And each type of these two states brings different challenges. Let's start with client state. Client state is the state that is owned by our application. It's often referred to either client or UI state. This state is temporary, it's local, and generally doesn't persist between sessions. Then we have our server state, which was the state that our application was mostly built upon, which is the state that's persisted remotely, is usually persisted on a database or something like that. And this state is asynchronous because we have to use synchronous APIs to interact with it. And there's no guarantees that this state is always up to date because, yeah, we might have a version of the state right now, but might be some changes on the database. Server state also comes with their bunch of challenges. It can be like data caching, doing some background updates, deduping requests, identifying and dealing with outdated requests, some performance optimizations like dealing with pagination or lazy loading data, and last, dealing with optimistic updates. So as we were using only server state in our application, it didn't make sense for us to keep using React context because, putting in perspective, we should use React context only for dealing with our UI state or client state. What we then started using was React Query. For those of you who don't know, React Query is a protocol agnostic collection of hooks for fetching, caching, and updating server state in React. And it's amazing. What we ended up doing was building our own custom hooks for everything we had in our context. Like, imagine that we have a context for dealing with authentication or with dealing with a to-do application or something. What we ended up doing was we created a custom hook for either doing use authenticate or use update to do or use create to do and stuff like that. So we'd create custom hooks using React Query inside of it, and this was so much easier, was more reusable because we didn't have to rely on context everywhere. We just spin off our own custom hook of React inside of the components that needed to use that server state. And yeah, we are so happy with it because it made so much easy to use it, because all the things that React Queries offers you, like caching your data or dealing with optimistic updates, and it's so amazing. React Query, you should all give it a check. And we used React Query for 6 months, I guess, and we still are using it. It's really amazing. But then we come to the conclusion that we were needing some type of UI state. We needed to share some data between components, and we thought, should we go back to context, or should we try to search for something new? And this is when we got to know wasnt. Wasnt is a state management utility that it's based on hooks, so its APIs are only hooks, and it has a really easy learning curve. It's so easy to use wasnt. Besides this, it also has transient component information, which means you won't have re-renders every time the state updates unless you want it to. You can also want to do that if you want, and it doesn't bring you context providers. It's so much easier to use, and it is the best of both worlds for us because we didn't have to go back to Redux or context, and wasnt took like half a day to configure and start using in our application. So yeah, I guess that's it for state. Now we come to the last part of our talk, which is testing. As I mentioned previously, we decided to migrate from class components to React hooks, and migration itself went well. Everything was working as it was previously, except right now we have almost half of the lines of code we had thanks to hooks, and everything was much readable. When everything was working really great, someone remembered, hey, everyone ran our tests, and this was what happened. Almost half of our tests were failing, so you could probably imagine that this was our reaction. We were left to wonder, what the hell is happening? Our components work exactly the same way that they did previously. So we did some research and we came to the conclusion that testing implementation details were to blame. Now, you might wonder, what are implementation details? Implementation details are the things which users of your code will typically not see, use, or even know about. And this is a quote by Kent C. Dodds. So, when we looked at our code, we came to the conclusion, yeah, our tests are deeply tied into implementation details. They were tied into things like the component state, tied into things like the props that the component received, and At the time, we knew that we had to stop using enzyme and move to the React testing library. Now, you might be wondering, why move from enzyme to testing library? Well, as I mentioned previously, we had been using enzyme for 2 to 3 months before we decided to migrate to the React testing library. And before anything else, it's important to mention that enzyme is really great and it supplies a huge amount of tools to test your components. The thing here is that often, if you don't worry about focusing on the user-centric perspective, you might end up tying into your implementation details. And here are things that I personally don't like about using enzyme. The first one is shallow rendering. Shallow rendering is the way that enzyme supplies you to render only the shallow part of your component. So if you have a component that has a children inside of it, it will only render the component part and won't render the component children. While this might be helpful in some scenarios, this is not the way that the user interacts with your component. When the user interacts with your component, it interacts with the component itself and with the component children. So only rendering the shallow part, we might end up forgetting to test something that we didn't even know that was necessary to test. The second part here is find. Find is the way that enzyme supplies you to query for stuff on the DOM. Well, find might be great. It allows you to search for things like the component name, ID attributes, and these are things that the user doesn't see or know about. So this is not particularly a great way to query the DOM for stuff while focusing on a user-centric perspective. And finally, the last point is state. This is, in my opinion, is one of the things that definitely ties into your implementation details. So when interacting with your component, the user doesn't need to care if the state of your component is 10. What the user cares about is, if I click on that button, will a model show up? Or stuff like that. So by tying your test into your component state, you're definitely tying into implementation details. So as I mentioned, the reason for leaving enzyme was to start using the React testing library. And with the React testing library comes its main guideline, which you can see here on a tweet by Can't See Dots. And it is, the more your tests resemble the way your software is used, the more confidence they can give you. Can't See Dots is the creator of the DOM testing library, which is the base library where all the libraries from the testing library family were built upon. So we have used the React testing library for over a year, and personally it changed the way that I write my tests. I became so much more interested in writing tests. It became so much easier, and yeah, our tests could survive real code migrations if we didn't change our implementation itself. So here are a couple of things that I personally am really happy with using thanks to the testing library. The first thing is React testing library promotes accessibility. By using queries that are accessible to everyone, which are the ways that we can search for stuff on the DOM, we can use queries that reflect the experience of visual, mouse-assistive technology users. And by granting priority to the queries that are most accessible to everyone, we will make sure that our tests find some accessibility issues in your components before we even find them on your application. Thanks to these queries that we can see here, which is the query by label text, the query by placeholder text, the query by role, the by display value, and the by text. Here we have a small example of how to use it in the React testing library. What happens basically is we render a component and we destructure our query and we query for stuff on the DOM. In this case, we are trying to query for an element on the DOM that has a label text called username. So this was one test that I started to use and made me understand that we weren't tying or area labeled by attributes properly in your components, and these are the types of things that the React testing library will help you find. The next great thing that the React testing library has is it lets you create your own queries. It has an helper which is the build query helper, and it's important to know that if we decide to follow the approach of building our own queries, we start by creating queries that promote a user-centric perspective instead of an implementation details one. And the third thing that I really liked about the testing library, it is user-focused events. The React testing library comes with a companion library, which is the user event library. And this library allows you to interact with a button. In this case, we are trying to do a click event on the button which has the name save on it. And what the user event library will do is it will trigger all the events that are usually associated with clicking with a button. Instead of just doing a firing of an event click, it will fire all the events like the mouse hover, the mouse down, the click, and all the events that are associated with the click process itself. And last but not least, it has a bunch of asynchronous utilities that you can use to query the DOM for stuff or do some specific assertions, either being by the wait for or the wait for element to be removed. So these are a couple of things that I really like about the testing library. So I've used the testing library for over a year by now, and as I mentioned previously, and as you can see from all this stuff on this past slides, React testing library is great. I personally started enjoying writing tests more than I did previously, and I definitely advocate for using it all over. So here are a couple of lessons learned and mistakes that we did while using it in the past year. And I'll start by the using ACT one. So using ACT. For those of you who don't know, when writing UI tests, there are tasks like rendering or firing events or doing some data fetching that can be considered as units of interacting with the user interface. ACT is a provider that React offers you to make sure that all the updates related to these units have been processed and applied to the DOM before you try to make any assertions. So, putting this in perspective, what we used to think about was, so rendering is a unit of interaction with the DOM and firing events is a unit of interaction with the DOM, so we should probably wrap all of them with ACT. The thing here is we don't need it, because React testing library already wraps all the utils that will interact with the DOM with ACT, so that you don't have to do it. So generally you never need to use ACT in your tests. The second mistake we used to do is using get by query with the assertion expect not to be in the document. So for those of you who don't know, get by query is a query that will throw an error when it doesn't find what it's looking for, but if it does, it will return that note on the DOM. So using a query that will throw an error with an assertion that we want to assert that something doesn't exist on the DOM is basically us begging for our test to fail. So instead of using get by queries to assert that something doesn't exist, we should use the query by queries, which is a query that will return null once it doesn't find what it's looking for. The next query is using await with fire event or on non-synchronous queries. So basically, this is pretty simple. We don't need to await for queries that are synchronous. Synchronous queries in the React testing library are queries like the get by and the query by, and we shouldn't wait for firing events on as well, because they are also synchronous process. So instead, what we should do is remove the wait. I had a question once that someone asked me, which was, but Daniel, I saw an example online where I'm using a wait on a fire event. And I did some research and it took me quite a while to understand what the docs he was looking at was the Vue testing library. It's only on the Vue testing library that firing events needs to be awaited for. Using await wait for with an empty callback. So for those of you who don't know, wait for is an asynchronous util for the React testing library that allows you to await for your assertion to pass. So if we provided an assertion, it will wait until that assertion evaluates to true. In this scenario, what we are doing is we are passing it an empty callback. So what it will do is it will wait one tick of your test before going to your assertion. While this might work sometimes, it doesn't guarantee that when it gets to your assertion, it will pass. So instead of doing this, what you should do is you pass your assertion to inside of your wait for, and it will loop it until it evaluates to true. Using cleanup. Cleanup is a util that the React testing library offers you to basically clear up the DOM after you do everything. So it would make sense that we use jest and we say, okay, after each test I want to run cleanup, right? The thing here is we don't need it. If we are using jest or a framework that supports the after each global, then the React testing library will automatically run cleanup for you. Using wait for with synchronous queries. So in this scenario, we are using the wait for util to wait for this query to validate to true. So we are going to wait until it returns a progress bar. So for those of you who don't know, there is actual an asynchronous query in the React testing library ecosystem, which is the find by. So instead of using wait for with get by query, we should use find by query to return to wait for what we are looking for. Using side effect instead of wait for. This one is actually a tricky one, but what we are doing is we are waiting for your use event to be clicked, and then we are waiting for our assertion to pass. Well, this might make sense on the first instance. This might cause you some unexpected examples, because as I mentioned previously, wait for will loop the code inside of it until it evaluates to true. So what might end up happening is you click on this button 100 times until this expect validates to true. So what we should do is we should remove the things that will cause side effects inside of our wait for to outside of it. So what we should do is pass your user event click to outside of our wait for, so it makes sure that it won't loop the assertion that we want to wait. So, well, these were a couple of mistakes that we had with the React testing library. Here is one thing that definitely gave me a couple of headaches during the time of using the React testing library, which is the error was not wrapped in act. So you might wonder, what is this error and what happened and how does it happen? So let's look at our code. Here we have a function which is called display Pokemon. This component basically returns a prop, which will be a function that will be responsible for getting our Pokemon data. And what we do is we have a state variable, which is if its component is loading, and we have a function called getSelectedPokemon, and this function receives a Pokemon. Once this function is called, it will set our loading to true, and it will fetch a request to our getPokemon data with our Pokemon. Once it ends, it will return the loading to false, or if there's an error, it will return the loading to false. On the render part of our component, we have a button that when clicked, it should basically trigger a request to get our Pokemon that it's called Pikachu, and we have a span that will show if it's currently loading or not. So you might wonder, how am I going to test this? This would probably be a test that we have. This test should call getPokemon with Pikachu. So the first thing that we do is we say I want to mock my getPokemon data function. So we pass it a jestfn. We render our component and we say I want this component to receive in the getPokemon data my mocked function. And then we click on the button that has the name Pikachu. Afterwards, what should happen? We should assert that the Pokemon data was called with Pikachu. So yeah, we assert if it was called with Pikachu. So we're probably thinking, yeah, this test is great, it's doing everything that we might need. So when we run our test, this was what happened. An update to display Pokemon inside of a test was not wrapped in act. When testing code that causes React state updates should be wrapped into act. So you might be wondering, well, why is this happening? I'm testing everything that we need. This warning is here to let us know that we are forgetting something into our test. What do I mean? Well, if we look at our test here, we are waiting that Pikachu is called, but we are forgetting something. There is actually something in my test that we are not covering, which is the set is loading. So this warning is there to tell us, hey, you are testing this scenario, but there is a state update that it's been called, it's been done after you end your test, so don't forget to test it as well. So before anything else, let's thank to the React team for giving us this heads up, and let's fix our test. How would we fix it? Easy. Or we use a wait for query to assert that basically the loading did disappear from the DOM, or we use the wait for element to be removed util to wait for our loading to disappear from the DOM as well. So yeah, that's it for testing. So this wraps my talk. I'd like to thank you all for watching. As you can see, it has a bunch of content because yeah, it was an entire process of growing an application for over 2 years and trying to figure out the ins and the outs and the whys of the React world. And yeah, I guess that's all from me. My name is Daniel Alphonse. Thank you for watching, and I'm looking really forward to seeing your questions in the Q&A section. Bye.